Hello everyone. Today's our topic is of class 10 science, that is acids, bases and salts. Our topic is acids, bases and salts. Acids, bases and salts. Students, it is very interesting chapter because it deals with our daily life. ठीक है, जैसे अगर हम लेमन वगैरह की बात करें, लेमन में क्या होता है, एसिड प्रेजेंट होता है, लाइक ऑरेंज में एसिड प्रेजेंट होता है, जो मतलब कि हमारी डेली लाइफ में चीजें उसमें सब. We will talk about acids. What are acids? Acids are that substances which give H plus ions, on dissolving it in water. On dissolving it in water. Acids are those substances, if we add in water, they will dissociate H plus ions. Example, we will mostly focus on three acids in this chapter. That is, first one is HCl, that is our hydrochloric acid. Next one is H2SO4, that is our sulfuric acid. And next one is our HNO3 nitric acid. We will discuss about chemical properties of these acids. Now we will talk about chemical properties of acids. Chemical properties of acids. First one is metal plus dilute acid. Metal plus dilute acid will give us salt plus H2 gas. Metal plus dilute acid give us salt plus H2 gas. For example, like if we have a lot of metals like potassium, sodium, calcium, aluminium, zinc, iron. If we take calcium, like for example, we take calcium plus dilute acid, we can regard here only two acids, that is HCl or sulfuric acid. For example, we will take here dilute HCl. It will give salt. HCl will dissociate into H plus and Cl minus. So as we know, valency of calcium is +2. So it will form salt, that is CaCl2 plus H2 gas. First one is metal plus dilute acid will give salt plus H2 gas. Upward arrow indicates that the gas is liberating. We take another example. Like we take example of calcium with dilute sulfuric acid. It will give calcium sulfate plus H2 gas. It will dissociate calcium sulfate plus H2 gas. As we talked about three acids, HCl, H2SO4 and HNO3. If we react metal with dilute nitric acid, we will get salt. Plus water. Instead of H2 gas. Here we take only two acids. First one is HCl or H2SO4. If we take nitric acid, there will be formation of water instead of hydrogen gas. Why it is so? It is because important question. Nitric acid is a strong oxidizing agent. Which oxidizes H2 to H2O. H2 to H2O. As we know, what are oxidizing agents? Oxidizing agents are that agents which reduces itself and oxidizes others. For example, addition of oxygen is what? Oxidation. That's why it converts H2 to H2. There is another one question, that is there any metal in which we react nitric acid, we will get hydrogen? Yes, there are only two metals, manganese, that is Mn, whose symbol is Mn, and magnesium. These are the two metals. These are the two metals. These are the two metals which on reacting with dilute nitric acid, liberates H2 gas. This question is very important because it's an exception. That is dilute nitric acid, we will get water instead of H2 gas, but there are only two metals, that is manganese and magnesium, on which reacting dilute nitric acid, we will get H2 gas. Next, we will talk about second property. Second property is reaction of metal carbonate, or we can write it as metal bicarbonate, or we regard it as metal bicarbonate on with dilute acids. What is the other name of metal bicarbonate? Its other name is metal hydrogen carbonate. Bi means hydrogen. It is metal bicarbonate. Bi means hydrogen, and we regard it as metal hydrogen carbonate. First of all, we will write general reaction. Metal carbonate plus dilute acid will give salt. In the previous one, we get hydrogen gas, but in this reaction, we will get carbon dioxide gas. How we can know? Because there is presence of carbonate. If there is presence of carbonate, we will get carbon dioxide gas. And at one time, if we want to remember, only one gas will be liberated. So there will be water, no hydrogen gas. Metal carbonate plus dilute acid will give us salt plus carbon dioxide gas plus water. For example, we will take an example like zinc carbonate, ZnCO3 plus dilute HCl, we will get salt, that is zinc chloride, ZnCl2, because zinc plus C is plus 2 plus CO2 gas plus water, Okay. If we instead of that, we will get, if we take sodium bicarbonate, like sodium bicarbonate, there will be formation of same thing, that is sodium bicarbonate plus dilute HCl will give its salt, that is NaCl plus CO2 gas plus water, These are our two reactions. Okay. Next we will move to our third reaction. Third reaction is reaction of metal oxide. Next is third is reaction of metal oxide. with with dilute acids. Okay, reaction of metal oxide. As we know, metal oxides, they are basic in nature. They are basic in nature. And in previous classes, we already know that acid plus base will give us what? It will give salt plus water. Acid plus base will give us salt plus water. As we already know that metal oxides are basic in nature, if we react acid plus metal oxide that is base, so it will give salt plus water. No type of gas will be formed, no hydrogen gas, no carbon dioxide gas. It is just like the neutralization reaction. That is, metal oxide plus acid will give us salt plus water. Okay. Example like metal oxide. अगर हम ले लें, here we take acid, that is our HCl, and metal oxide. If we take like sodium oxide, if we take calcium oxide, suppose, so it will give salt, calcium chloride plus water. Calcium chloride plus water. Here these are the three chemical reactions, or we can say that chemical properties of acid. Physical properties, as we already know that acids are sour in taste. Acids turn litmus red. We have read in previous classes. So now our next topic is identification. As we said that in first reaction, H2 gas is liberated. In second reaction, CO2 gas is liberated. How can we know that these two gases are liberated? So, question is, first of all, we will talk about identification of H2 gas. Identification of H2 gas. How will we identify that H2 gas is liberated? As we know, hydrogen gas is highly flammable. H2 gas is highly flammable, or we can say that highly inflammable. So when we bring, suppose there is a beaker in which hydrogen gas is liberated. Okay, suppose we have performed a reaction and due to which hydrogen gas is liberating. If we bring here a candle, if here we will bring a candle, it will produce popping sound. It will produce popping sound. If we will bring a burning candle, it will produce popping sound. That will indicate that hydrogen gas is liberated. Now, next we will proceed about how we identify that CO2 gas is liberated. Okay. Now, next is identification of CO2 gas. Very important. Identification of CO2 gas. Next is identification of CO2 gas. How will we identify that carbonated gas is liberated? So, as you know, what is the formula of lime water? Formula of lime water is that is calcium hydroxide. Calcium hydroxide. Okay, it is the formula of lime water. Its other names are, its name is lime water, or we can regard it as slaked lime, or its name is calcium hydroxide. Okay, very important formula. In chapter 1, you also study about that. What is slaked lime? What is quick lime? Okay. When we will pass lime water, when will we pass CO2 gas, it will give us calcium carbonate. As we know, calcium carbonate is the formula of marble. So it will give us white PPT. So one question is also there, that if we pass CO2 gas in excess, then there will be the formation of white PPT or not. Okay, let's see. Suppose calcium carbonate is already formed. When we then we also perform CO2 gas, we will get calcium bicarbonate. We will get calcium bicarbonate, which is soluble in water, which is soluble in water, which is water soluble. If anything is water soluble, then there will be no formation of PPT. Then there will be no formation of PPT. So there will be no PPT. There will be no formation of any PPT. So we can write it as lime water plus CO2 gas will give calcium carbonate. If we write it as calcium hydroxide plus CO2 gas excess, it will give calcium bicarbonate, which is water soluble. There will be formation of white PPT. If there is formation of white PPT, then we can say that CO2 gas is liberated. If it is in excess, there will be formation of calcium bicarbonate, which is water soluble. Then there will be not any formation of white PPT. Okay. Next we will talk about chemical properties of bases. As we have discussed about chemical properties of acids, now we will discuss about chemical properties of bases. Okay. Next is chemical properties of bases. Chemical properties of bases. Chemical properties of bases. Okay, first we have discussed like metal plus dilute acid. Same thing, metal with base. Metal is general reaction. Metal plus base will give what? That is salt plus water. Metal plus base will give salt plus water. First of all, we will discuss about what are bases. What are bases? Bases. Bases. What are bases? As we have discussed, acids are those substances which give H plus ions on dissolving it in water. Then there will be in bases, there will be OH negative ions, so we can write it as hydroxide ions instead of H plus ions, when we called it as bases. Okay, bases are those substances same which give OH minus ions, that we can write it as hydroxide ions, that we can call it as hydroxide ions. तो अगर हम examples की बात करें, if we talk about examples are like sodium hydroxide, it will give OH minus ion, like potassium hydroxide, magnesium hydroxide, aluminium hydroxide, etc., which give OH plus OH negative ions. Then we call it as bases. Okay, now we will move to first property, that is metal plus base. Metal plus base will give salt plus water. Okay, example like zinc, and we take sodium hydroxide as a base. So it will give sodium zincate, Na2ZnO2. You have to remember the formula, plus water, sodium zincate. Now we will proceed to our second property. There are only two properties. Instead of acids, we will talk about three properties, but in bases, we will talk about only two properties. Next one, second property is non-metal oxide. Okay, plus base will give, there will be formation of hydrogen gas. Metal plus base will give salt plus hydrogen gas. Same as in case of acids. Okay, salt plus water. Here will be non-metal oxide. For example, carbon dioxide plus base we can take like sodium hydroxide. Okay, then we will get salt, that is sodium carbonate plus water. Sodium carbonate plus water. It is our base. And as we know, non-metal oxides are acidic in nature. These are acidic in nature. So it is like acid plus base will give salt plus water. It is also a neutralization reaction. It is also neutralization reaction. So we have discussed about acids, bases. Acids are those substances which give H plus ions, and bases are those substances which give OH minus ions. We have studied about three properties, chemical properties of acids. First one is reaction of metal with dilute acids, reaction of metal oxide with dilute acids, reaction of metal carbonate bicarbonate with dilute acids. Next, talk about identification of H2 gas and identification of CO2 gas. Next, we talk about chemical properties of bases. Metal plus base will give salt plus hydrogen gas, and non-metal oxide plus base. If non-metal oxide are acidic in nature, will give salt plus water. So, in introduction, we will talk about one more thing, that is salt. How salts are formed? How salts are formed? Simply, same thing. When we react acid with base, we will get salt plus water. Most important neutralization reaction is, most familiar neutralization reaction is, we can write it as acid, that is our HCl, plus base like sodium hydroxide, and it will give sodium chloride plus water. Sodium chloride is what? It is a table salt. Okay, it is a table salt which we use in our houses. Okay, that is our how salt is formed. Acid plus base will give salt plus water. Okay, next term. Have you heard about term that is strong acids, weak acids, strong base, weak base? Have you heard? Okay, very good. Okay, first one is, we will talk about strong acids. Strong acids. So, if we talk about strong acids which are fully dissociate, which get fully dissociate. If we fully dissociate, for example, if we talk about HCl, suppose there are 100 molecules are there. There are 100 molecules of HCl. We will give H plus Cl minus. Suppose if 100 molecules break, we will get 100 H plus ions and 100 Cl minus ions. Because how? Because it is a strong acid. It fully dissociates. Like if there are 100 molecules of HCl, fully dissociates, we get 100 H plus and 100 Cl minus. Suppose we have a weak acid. Like carbonic acid. As we know, carbonic acid is a weak acid. Suppose there are 100 molecules of carbonic acid. Okay. Suppose weak acids are those which partially dissociate. If we suppose there are only 50 molecules break, then we will get H plus but 50. We will get H plus only 50. So in simple language, we can say that strong acids are those which give more H plus ions. And weak acids are those which give less H plus ions. I hope this is clear to you, that how we can see that strong acids will give more H plus ions because it fully dissociates, and how can we say that weak acids will give less H plus ions due to it dissociates partially. If it dissociates partially, no all molecules will be broken, and we will get only few H plus ions. Same in case of acids and bases. Same thing in case of bases. Same thing in the case of bases. Okay, strong bases. As we already have discussed, that bases are that which give HOH minus ions. Okay, so it we can say that which will give more OH minus ions. That will be regarded as strong acids. Example like sodium hydroxide is a strong acid, like potassium hydroxide, it is also strong base because it will dissociate into Na plus and OH minus, same as it in case of potassium hydroxide, K plus and OH minus ions. Okay, strong bases which will give more OH minus ions. If we will talk about weak bases same as in case of acids, that will give less OH minus ions. Less OH minus ions. For example, like aluminium hydroxide. Okay, aluminium hydroxide. Here next term is like, have you heard about the term alkali? Have you heard about the term alkali? There is a major difference between alkali and base. Sometimes one more question arises, what is the difference between alkali and base? What is the difference between alkali and base? So I think we will discuss it also, and then will we wind up our topic. Okay. Now we will heard about term alkali. What is alkali? Alkali is a type of base which is soluble in water. Alkali is a type of base. Alkali is a type of base which is soluble in water. Which is soluble in water. Alkali are those bases which are soluble in water. For example, alkali. Like have you, if you study about 5th chapter, that is periodic classification of elements, then you came to know that what are alkalis. Alkalis are group 1 elements like sodium, potassium, lithium. Okay, so alkali like NaOH. If we talk about alkali is like NaOH. That is our sodium hydroxide. KOH, that is our potassium hydroxide. Because why these are alkali? Because sodium, potassium, all are alkali metals, and with OH minus ions, they become base. Okay. So one term we can write it as, one crux we can write it as, all alkali are bases. All alkali are bases, but not all bases are alkali. All alkali are bases. All alkali are bases, but not all bases are alkali. Why? Because alkali is just type of base which is soluble in water. Okay. So we can, alkali is a base, alkali is just a base, but not all bases are alkali because all the bases are not soluble in water. All the bases are not soluble in water. So I hope this clears your topic. If anyone has any doubt, please comment and ask me if you have any doubts.